Continuing from the big O complexity discussion of the greedy 2 algorithm from class, I've added one slide to eLearn which calculates the big O complexity. So remember in class we said it's big O of n cube, right? So let's see how we can figure that out. So remember there are two sets. One is the set S, which is the initial set of cities to visit, and then there's the set T, which is initially empty but has the current tour, right? So if you recall the greedy 2 algorithm, it starts by finding the closest pair of cities. So after the first step, you have two cities in T, and in S you have n minus 2 cities, right? So if you remember from our example, it was something like C, D, C, and the rest of them were in this set, right? Now let's see the number of operations that happen at each iteration. So from here, in every iteration of the while of the loop, we actually pick up one city from this set and add it into the city of the tours, right? So we end up doing n minus 2 iterations. Now at each iteration, what do we have to do? First, we have to figure out from this set T, between the set of cities in T and S, what is the one with the closest distance, right? So for example, if there are two cities here, for each of those two cities, you have to look at n minus 2 possibilities, right? So in our example, in this case, we would look at CA, CB, CE, CF, CG, DA, so on and so forth, right? So that will give you the minimum distance, which is the next edge that we will add, right? So we need to do 2 into n minus 2 comparisons to figure that out, right? Once we have that, remember we still have to compute the total route length, right? Now if you add one more city here, there'll be 3 cities, so you can compute 2 times 3, which is the route length that you need to compute, and then we choose one which is minimum, right? So to go a tour of 3 cities, you might have to go down to the set once, and then to compute another one you may have to do it again, so it will be 2 times 3, right? Now similarly, in the next iteration, you'll have 3 cities here, you'll have n minus 3 cities. So you'll take n 3 into n minus 3 steps plus 2 into 4 steps, right? And so on and so forth, all the way till n minus 2, because we've already taken 2 cities out in the initial step, into n minus 2 plus 2 times n minus 1, right? Now this expression, if we simplify a little further, we can see, so here what I've done is we need to add all of these steps, right? So this is in each iteration, these are the number of steps. So you need to add all these steps up, right? And if you want to add, the way I've added it here is, I've just combined all of these together, right? So we have 2n minus 4, which is 2 times n minus 4, plus 3 times n minus 9, plus 4 times n minus 16, 5 times n minus 25, and so on all the way till here, which is the last expression, which is n minus 2 times n minus 2 square, right? Plus on this side, what you have is just a summation of this series, right? So 2 times 3 plus 2 times 4 plus so on and so forth till 2 times n minus 1, right? Now if you try to simplify this expression a little, you can actually group all of these first terms together. So we have 2n plus 3n plus 4n all the way till n minus 2n, and then minus, we group all the other expressions together, so 4 plus 9 plus so on and so forth, right? Similarly here you can take 2 because 2 is common, and then you will have this expression inside, right? Now if you take n out here, you end up with this arithmetic series, 2 plus 3 plus 4 plus all the way till n minus 2. This one is actually a geometric series, right? So if you recall, the sum of a geometric series, the squares, 1 square plus 2 square plus 3 square plus 4 square all the way till n square, is actually n into n plus 1 into 2n plus 1 by 6, right? So here I've given approximate. So this is like 2 terms are missing here because it's only till n minus 2. It will be something like this minus some 2 terms. But I say, okay, approximately it's gonna be this. Similarly here, the formula for arithmetic series, it will be first plus last by 2, right? But here I've say approximately, because here also you see two terms are missing, so I just say it's approximately n into n plus 1 by 2, right? And that's the same term here. Now if you simplify it further and multiply, you'll get something like this, which would be n cubed by 2 plus n square by 2 minus n cubed by 3 minus 2n square by 3 minus n by 3 plus n square by 2 plus n by 2. Right, now if you just simplify this, so we have a cube here, we end up with n cubed by 6 plus we have n square here, n square here, n square here, n square by 3 plus we have n by 6, right? Now in these two are the dominant terms. The dominant term is going to be around n cube and 6 is a constant. So in the end, we'll end up with the complexity of big O of n cube.